Hello students. Today we are going to discuss about random oracle model. See, this model itself is saying that we are going to utilize an oracle, that is a database. The database which we are going to utilize is for the purpose of storing your message with the message digest. Right. So it is a form of a dictionary type where we will be having the key pair combination. Thus, we are going to save our data with its message digest, right? So let us move with its definition first of all. Coming to the definition part, see here, the Oracle model is designed specifically for this hash function purpose. See, the hash function output and input, as we know already. So the hash function is a type where where this hash function will be taking the input as a message, that is a plain text, right? So this message will be given to the hash function. The output of the hash function which we are getting is the message digest. See, this message digest is in the fixed length format. See, if my message is of the format, let me say my message is just 8 bits data. Even though if it is 8 bits, if I'm providing this to the hash function, depending on my hash function output, if it is of 128 bits, my message digest will be giving me 128-bit length of output. That is a message digest, that is a hash code. Even though my message is of 100 lines, these 100 lines also, if I am providing to the hash function, as my hash function can give 128-bit fixed length of data, even though 100 lines of data will be providing 128-bit length of fixed length of output. So this we know already, right? So this is a basic introductory part of our hash function. Now, when we have this hash function in our hand, why this random oracle model is important to us to know? This model behaves as a mathematical model where we will be storing the message digest as a fixed length, right? So how I am doing this is just if I take my message as NGIT, right? So the NGIT word will be universally given with one unique code that is called as a message digest, right? Now, my Oracle model will be storing this NGIT's unique code in the database as a record, right? So when this NGIT is a new message, see the first point, when it is a new message of any length given, then the fixed length of message will be generated for this, and this will be stored in the as a record in the database. Message digest will be stored in the database as a record, right? If my NGIT word is already existing in the, I mean the message digest, if it is already existing in the database, just the thing is I have to retrieve the digest from the record. That's it. I'm not going to send this message to generate hash code once again, if because it is already existing. This the message which is given for which the digest exists already, right? So if the digest exists already, there is no need of generation with the hash function for the fixed length of code, because any message which we are giving will be uniquely generated throughout the universe. Thus, whenever I get that message, immediately I will be forwarding to the hash function and it will be giving me the digest. Immediately after that, we will be storing that as a record with a message and a message digest as a key pair value, right? So this is the format of the random oracle model. Now, when we are utilizing this model, we after a number of analysis part and the survey about this random oracle model, we came to know about two important problems actually. These are the two problems. The first one is the pigeonhole principal problem and the second one is the birthday problem. See, the pigeonhole principal problem is nothing but we will be having n pigeonholes, but we may have more than n pigeons which are occupied. So how can I say this? See, if I have 4 pigeonholes, if I have 4 pigeonholes, and I have, see, when I have 4 pigeonholes, I can have a chance of having 4 plus 1, that is 5 pigeons occupied. So let us say this is pigeon 1 and this is pigeon 2, this is pigeon 3, and there is a chance that pigeon 4 and 5 occupied in the last hole, right? So this indicates that this is nothing but we may have a chance of having more than 2 messages having same message digest. One or more messages, one or more messages, one or more. See, I'm saying more means many. One or more messages striking to the same message digest. So that is what the pigeonhole is saying. I have 4 messages means I should have 4 message digests. Yes. So instead of this, what happening is I have 4 message digest available, but I have 6 messages included. So this is what, see, n number of messages are giving with a 1. See, the relationship which we are showing here as a many to 1, like many messages, 1 digest, many messages, 1 digest, right? So this is a chance of getting 1 or more messages after calculation of the hash function and all. They may have same hash code generated as an output. So the word NGIT and the word KMEC both may be striking to the same message digest. So this is a type of a collision attack where we can see. So like this will lead us to the collision attack, right? So this is what the pigeonhole principle is. Now the second thing is a birthday problem. See, this birthday problem is also called as a birthday paradox, where this will be showing all the vulnerabilities of the system to us. So I can show you this in the existing cryptographic algorithms, how it will be actually. See, coming to the birthday problems, here there are 4 problems which we can see here. The first problem which I am about to say is we may be having one predefined value, message digest value. So which we will be like as an attacker point of view, or else anybody to have knowledge about this. So what they will be doing is they will be taking the predefined value, let us say the message digest. Okay. So the attacker point of view, let us discuss. So the attacker will be checking in the Oracle model for same message digest in the set of records. So he will be setting one predefined hash code, that is a message digest, and he will be searching for the same message digest in the set of values. So that is nothing but the first problem. So if we get that message digest, directly they can enter into their credentials with respect to the password storing and all kind of things. The second type is nothing but there will be one digest which may be same, like which may be same with other record in the same set of values. So there will be one set which is always equal to the other set in the same set of values, right? So the third one is nothing but we will be equalizing. See, there is no predefined one like this. We are going to check. There will be n number of digests which are equal to each other. So we start finding that kind of cases. The last one is 2 or more sets of values, 2 records, 2 databases, which are equal with the same message digest. So we keep on observing for this kind of thing. So for example, I'll give you a small example for this. In a single shot, it is very hard to understand about this. So let us go with one of the thing. See, when we are discussing about hash function, the value, let me go with the password. See, when I say password, my database, so let us go with NGIT database. In my database, what I did is I have a username and a password. So when I have username, it will be asking me to go with the password, right? When I have username, it will be asking me to enter with the password. Now, once I enter with the password, this password will be generated with the hash code, that is a message digest, and store in the Oracle model. Done. Now, this is user one credentials, right? Now, attacker entered and he set one common predefined message digest, and he is searching for the message digest in the NGIT record, which is suitable with this message digest. Once they get the message digest which is equal to this type, so immediately we can say that the credentials, I mean passcode credentials are with them, and they can enter as user one into NGIT website. Got it? So the next one is about set value. See, I have set instead of predefined value, they took one word like two or more users. I mean, user one and user two may have same message digest in the list. So user one, they will take one user. Okay, they will take one user and start observing for this kind of message throughout the website. I mean, throughout the record. Okay, so this is a throughout the database. So this is what is the second problem. The third problem has several variation. Then see in the second problem, we will choose one thing and we will start searching which is related to that. In the third one, we will not choose one thing at all. We will start finding among the record where can we get two digest equal. Where can we get two digest equal after analyzing whole records? So this is the third problem, right? And the last one is, see where I am saying this is NGIT and this is KMEC. So if I am considering two databases, let me go with my username and credentials for NGIT KMEC are same. Okay. So as a security person, I can give you one tip that nowhere you should have same passwords to many websites. You should not have same passwords to many websites, because one website, if it is vulnerable and your passcode over there is revealed, then the other websites data also will be into the hands of the hacker. So that is what the fourth problem will be saying to us. See, once the set of NGIT record is revealed, so this passcode will be searching in other websites which the user is about to communicate. So this is KMEC website, like that. I have some other website called college.website. So like this, we can have n number of websites or applications with the same passcode, pass value. So the message digest is revealed over there, right? So this is the fourth problem which we are going to analyze in detail, right? So these are the birthday problems in random Oracle model. So thus, after a whole analysis, we can understand that the attacks which we are facing today are two types. That is a birthday attack. So this attack may be of any type depending on the collision types. And the second attack is of the type where we have discussed this pre-image and second pre-image about the revealing of the message directly, revealing of the hash code directly. Okay, so this is this type we already discussed in the cryptographic hash criteria. Just go through that once again. If you have any doubt, there we have discussed in detail about it. So the pre-image is nothing but we are going to find the input message directly, which is mapped to the hash code. Right. Second pre-image is nothing but we are going to find the hash code which we have already, and we will be searching for the same hash in the output. Okay. So this is what the part of random Oracle model. If you have any doubts about this, just feel free to contact either in the college or through comments. Thank you.